Let's have a look at a couple of questions where we're asked to do an addition or subtraction, and our numbers are in scientific notation, but the powers of 10 are not the same. This causes a bit of a problem for us because generally we know that when we're dealing with numbers in scientific notation, we can add or subtract the digits as long as the powers of 10 are the same, and that's pretty easy. But when they're different, we can't go ahead and add or subtract the numbers. So in this case, I can't subtract 2.1 from 5.67 until I've got those numbers written as like terms. In other words, I need the exponents on the 10 to be the same. This is okay. This is a quick fix. We just simply have to choose one number to adjust, and we're going to adjust the exponent so that it matches the exponent of the other number. It's actually okay to adjust either one of these exponents. There's not a wrong way to do it. So you could go ahead and adjust this exponent to be 10 to the 5, or you could go ahead and adjust this one to 10 to the 6. I'm going to show you in a moment that either route will get you to the right answer. You just got to be careful that you're adjusting them correctly, and then you've got to be careful about your sig figs when you're doing the addition or subtraction. But if you do that, you're going to be just fine and you're going to get the right answer. Some common sense is usually helpful here. When we look at these two numbers, we can see that 10 to the 6 is a bit bigger number than 10 to the 5. So we're doing a subtraction. It would be a good idea to have these both written as 10 to the 6. So let's go ahead and adjust the second number so that it has the exponent 10 to the 6, and then we're going to be subtracting it, okay, from this bigger number. Again, you could go the other route and it will work out. But let's go ahead and do this for our example that we work out together. So I'm going to start by adjusting the second number to be exponent 6 instead of exponent 5. So we'll go ahead and bring up our question. And let's think about how we do that. If I'm going to adjust the exponent on the second number to be larger, I'm going to be multiplying that by 10, or in other words, I'm going to raise the exponent by 1, okay, which is equivalent to multiplying this number again by 10. If my exponent is going to get bigger, then I need to compensate by adjusting my digits to be smaller. So in other words, if I'm going up by exponent 1 over here on my power of 10, I need to move this decimal place over to the left by 1 as well. You're always compensating. So if your exponent's getting bigger, your number's getting smaller, and vice versa. So we can go ahead and adjust this number now and rewrite it as 0.21 times 10 to the exponent 6. And I can ignore that number there. Now I've got both of my numbers written in scientific notation with the same power of 10. I've got like terms, so I can go ahead and subtract my digits. So these are numbers here. I can go ahead and subtract them. So let's do that off to the side. I've got 5.67, subtract 0.21. I'm always careful to write my, you can do this in your calculator, but I'm doing this mental math, and I can go ahead and I want to, if I'm going to do it mentally, make sure I line up my decimal places. So 7 minus 1 is 6, 6 minus 2 is 4, and 5 minus 0 is 5. So I've got my answer. Before I go ahead and tack on my power of 10, which would be the next step, I need to think about sig figs right now. As soon as you're done your addition or subtraction, that's when you want to think, how many sig figs am I really allowed to have in this answer? And because it's an addition or subtraction question, we're using sig fig rule number 1, which tells us that we have to round our answer to have the least number of decimal places in our question or in our data. Can't have an answer that's more precise than your data. Both 5.67 and 0.021 have 2 decimal places. So that's helpful, and that means our answer also has to have 2 decimal places, which it does, and that's great. So I don't actually have to round this. I'm good to go. Finally, before I finish up my answer and I report it, I need to put my power of 10 on there. So I've got 5.46 times 10 to the exponent 6. And when I look at my answer, I see that it has not only the correct number of digits, it also is written correctly in scientific notation, so I'm happy with it, and that's my answer. Let's do another example. In the question that we just worked out, we were dealing with positive exponents, which are great. We like positive exponents, they're easy. When we have questions with negative exponents, not a problem, but sometimes students have a little bit more trouble with negative exponents. So let's work out a question where we have negative exponents, and here I'm going to show you that no matter which root you choose, whether you change this exponent or you change the second exponent, we're still going to get the correct answer. Looking at these numbers for a minute, if you think about the powers of 10, this first number here, 5.4 times 10 to the negative 4, has a smaller negative exponent than the second term over here. Negative 4 is a smaller negative exponent than negative 6. What that means is that this first number is actually a bigger number as compared to the second value. So this second value is actually a smaller number. Okay, the bigger the negative exponent, the smaller that number is. So we're doing an addition, and it might make good sense to us to decide to go with the smaller negative exponent, or in other words, go with the bigger value here. So we could change this exponent to be negative 4 to match the other one, and then do our addition. Let's start with this root first. I'm going to show you how they will work even if we went the other direction. Okay, so we're going to change our exponent here, negative 6, to be negative 4. How are we going to do that? Well, we're going to raise it by 2 exponents. We're going to raise it to negative 5 and then to negative 6. And to do that, I'm going to multiply by 10 to get us to negative 5, and then 10 again to get us to negative 4. In other words, I'm going to multiply by 100. I'm raising that exponent by 2, up by 2. And whenever we make our exponent bigger, or a power of 10 bigger, we need to do the opposite to our digits to compensate. So if I've gone up by 2 exponents, that's representing a bigger number. I need to go over to the left by 2 decimal places. So 1, 2, and I'm going to put that new decimal place right there. Let's rewrite that number, filling in our 0. That's going to be 0.093, okay, times 10 to the negative 4 now instead of negative 6. I've multiplied by 100 to raise it up to negative 4, and I've moved my decimal place over 2 spaces to balance that out. Now I can ignore this, and I look at my 2 values and I see that I have the same power of 10, so I am good to go. I can add my digits now. This is an addition question. So let's go ahead and add our digits together. I'm going to do this off to the side. I've got 5.40 plus 0.093, lining up my decimal places. I know often in chemistry we tend to just whip out our calculators and put it in, and nothing wrong with that. Just pay attention to decimal places when you round your answer. But when you do it this way, it actually helps you understand why and where we round off our number. So let's go ahead and add these together. So 0 or nothing plus 3, we're going to bring down the 3. 0 plus 9 is 9, 4 plus 0 is 4, and 5 plus 0 is 5. Okay, let's think about our decimal places before we move on. The first number has 2 decimal places. The second number has 3 decimal places. So we're rounding right here after the second decimal place. Okay, because our final answer can't be more precise than this value right here that has 2 decimal places. And it's important that we do this step right here. So we're going to say right now is the time to round off our answer so that it has 2 decimal places, and then we can go ahead and pop on our power of 10 and finish up our answer. So to rewrite this out, it's going to be 5.49. If I look to the next number, which is a 3, it is not great enough to round up that 9, and so 5.49 is going to be our value. We're just going to drop that 3 off. And now it's time to bring down our power of 10. So 10 to the negative 4, okay, was the like term that or the power of 10, our like term, and we can go ahead and say that our answer is finished. Not only does it have the right number of sig figs, 2 decimal places in our answer, but also it's written in correct scientific notation, so we're happy with it. Let's go ahead and do this question one more time, but this time we're going to change the other exponent. And the only reason we're going to work through it this way is to show you and prove to you that your answer will work out no matter which direction you take. So in the last example, we changed both exponents to be negative 4. This time we're going to change both exponents to be negative 6. So that means we're going to adjust this one right here to be negative 6. So let's think about how we do that. Bring up the same question, and if I'm going to make this exponent a bigger negative, I'm actually going to be dividing it by 10 2 times to bring it up from negative 4 to negative 5 to negative 6. Or in other words, I'm going to be dividing by 100 to make that exponent 10 to the negative 6. When my power of 10 is getting smaller, which it is, a bigger negative is a smaller number, and so as my power of 10 becomes smaller, I need to adjust my numbers, my digits over here, by the same magnitude, but I've got to make sure that this number is getting bigger because I've made my exponent smaller. So I'm going to go move my decimal place 2 spaces to the right. Okay, I've essentially raised my or made my exponent smaller by 2, so I'm going to move my decimal place over to the right by 2. And so now our number looks like this. We've got 540 decimal place right after the 0 times 10 to the negative 6. Of course, this is not a number that's written in nice scientific notation, but that's okay because we're only doing this for the purposes of being able to add our digits together and do our calculation. So now we've got, we'll ignore this. We've got both numbers now written with like terms, same powers of 10, so we're ready to go ahead and add up our digits. And stick with me for a moment here. So 540 decimal place after the 0 plus 9.3. Okay, bring down my 3. 0 plus 9 is 9, 4, and bring down the 5. 549.3. Before I go ahead and pop on my power of 10 and say I'm done, we need to think about our sig figs and how many decimal places am I allowed to have in this answer. Remember the rule, sig fig rule number 1, we have to round our answer to the least number of decimal places in our question. So if we look at these two values, we can see that the first value, the decimal is right after the 0, and there is no 10th decimal place there. So we are rounding our answer. Our answer is limited to the tens place, okay, the number before the decimal. In other words, this 3 here is not going to be significant. We're going to have to take that off of our number. So before we go any further, it's really important that we apply that sig fig rule right there. So our answer is going to be 549. That's got the correct number of sig figs, times 10 to the exponent negative 6. Now, we're not quite done because this number is not written in proper scientific notation the way we would like it. Correct or proper scientific notation always has just one number before the decimal place. So we're going to have to bring this decimal place over 2 spaces to get that number to be written in scientific notation correctly. And now let's think about what's happened to our exponent when we did that. Remember the rule: if your digits if your digit is getting smaller, in other words, you're moving your decimal place to the left so that the number is smaller, 5.49 is smaller than 549, we need to make sure our exponent is getting bigger by the same magnitude. So if we moved it over 2 places to the left, which is kind of like dividing by 100, we're going to make sure that we multiply by 100 over here. Okay, or we multiply by 10 and then 10 again. So we moved it over 2 spaces to the left, and we need to make this bigger by the same amount. So we're going to raise this up by 2. Okay, it's the same as saying negative 6 plus 2. So our answer is going to be negative 4. The first time we multiply by 10, we go negative 6 to negative 5, and then we multiply 10 again, and we have negative 5 to negative 4. Now our answer is written correctly in scientific notation. It does have the right number of sig figs. If we come back here for a moment and think about how we wrote our answer here, we applied our sig fig rule right after the addition, which was the right thing to do. So we knew that we had the number written with the correct number of sig figs. In total, there's 3 sig figs in the number 549. So once we adjust the number in scientific notation, it should still have 3 sig figs, which it does. So it's written with the right number of sig figs, and it's written in scientific notation correctly. And you'll notice that we got the same number as we did in the previous example, where we changed the exponent to negative 4 instead. So either way you approach it, it will work out.